version and
Try to speak to the microphone.
you hear me?
Yes, but better. Just a second, maybe I can increase. Oh, yes, I can increase volume. Yes, please.
Okay, so I put the new version in Colab. So yeah, it still outputs the after that. So it kind of runs a simulation where you choose an action from the optimal actions, and then it decides the next state based on random number generation, and then that gives you the cost. And so each time you choose an optimal action, it changes what the slope is. So here it shows you what the slopes are at each point in the simulation. So in some, like if you're on an edge point, you might have a different minus slope and plus slope. So that's what these two are showing. Or in some cases, it might just be the same. And then the risk levels, that's the Y state. So again, in some cases, you might know exactly which Y you're at if you're on an edge point. Otherwise, you'll have like an interval of Ys here. And so the risk level changes according to the simulation. If you choose one risky action at the beginning, then you'll have to be less risky as the simulation goes on to maximize.
Just a second, Thomas, I'm trying to understand what you're doing. So you develop a simulator for a Markov chain, yeah? Control Markov chain.
Yeah, I basically just followed what was in this.
But the first step should be that you should find the optimal, you should find the optimal value function.
Yeah, that's part of this.
It's already done, yeah?
That's what we talked about last time.
Okay, so just a second. Let's go back. So basically, there are two steps. One step is you have a model, you have initial state, you have initial risk level, and you have a horizon, yeah?
Yeah.
Okay. Then you do value iterations and you find the value function, yeah?
Yeah.
And then you run the software and you run the algorithm, yeah?
Yeah.
Okay. And now probably the next step will be to try to verify in simple examples two things.
Sorry, folks, stop in about 20, 25 minutes. Will be okay, but at all paper, only 3 doors will be opening. You must thank for that.
Okay, so the question is what, just to calculate, probably do it several times, multiple times, and collect some statistics to verify that it's indeed such and such policy.
Yeah. Yeah.
Because from one run, you cannot have the optimal value.
Yeah. So
you can compute it, but you cannot.
Yeah, I guess I could like continuously run the simulation like to collect statistics, or I could try some other examples of like simple Markov chains to make sure that it makes sense.
What I'm trying is the following: you have one problem. Then you have an algorithm that allows you to run it one time. But once you run it one time, then you just, as a result, you have the total reward here.
Yeah, that's right.
Yes. Now, if you write it multiple times, you have the realization of the random variable. And if you average them, you should be able to see that the objective function is the right one.
The objective function being the CVaR minimization?
Yeah. So even if not CVaR, it should be the value of that you computed, which is CVaR, some kind of, which is this is adjusted CVaR.
Okay.
So then will be complete, not complete, but more or less reasonable computation, verification by computation, which you don't need it if you programmed it right. But this is the way to see whether everything is programmed right.
Okay. So do you
So
want
this is
like
one thing.
do you want like a graph, like so run the simulation many times and then like do like a histogram of the total cost, like something like that?
Not the histogram even if you compute the average, histogram is okay. But if the number of experiments goes to infinity, then it should go to in the limits to the value function on
Okay.
average. Yes, and of course, if you do histogram, you will see this finite n. N is finite with the finite number of repetitions. Yeah, I think to have some kind of hands-on experience and demonstrate it would be good. Yeah,
Yeah.
this is one thing. After that, we'll see that it's completely programmed and verified. And then I ask you to run the example in the paper. If it is possible to reconstruct.
Okay.
Because the paper has a financial example.
Yeah. Okay.
Will be the last step, the next step. Yeah. Okay.
Okay.
Well, Jefferson, do you have anything else? I'm still working on the revision, so I need slightly more time.
I guess just maybe a quick question. So the simulation here is just for the purpose of verifying that that the policy you derive from the value function is the right one, or it seems to be the right one?
Yeah, I mean, I did this because I was just following the instructions in the paper, and then I realized.
Yeah, no. Let's do
Yeah.
something slightly more, because this is a tricky field, and there is a good paper in this field. I think I sent it to you. It is the paper by Marek Petri. Also apply what you have to his example as well, which is very simple, but it's a counterexample. And there we will have some kind of, we need to sharpen our intuition for that example as well. You even can present that example to us, because it will be good for us to have deep understanding of that example. This is example showing that CVaR we are working on is not real CVaR. Okay. And I should tell you that the fact that it's not a real CVaR is not that bad, because some giants in this field, like Shapiro or Rodzinski, they claim that the real CVaR is not good. It doesn't satisfy certain time consistency properties. And this one, I think, satisfies them. Okay?
Yeah.
So if we don't have anything else, that I think we should move ahead. Yeah?
Yeah, I think I'm good to move ahead.
Okay. Hello?
Yes.
Do you have anything to discuss?
I think okay, we need to ask Thomas to finalize the algorithm on one hand, and then we will try to use PyTorch besides NumPy to use some approximations in the continuous version of this algorithm, when the state space and action space will be not finite or countable. And
Hello, I
yes.
have a question. I have a more relevant question, but a question. Yes, we can do this, but not, the question that I have is, even for the discrete versions that he's working, maybe when n is large or infinite, maybe also we can find neural
Of
net
course,
algorithm.
of course. Then I think we need to try some inventory control problem or something like this.
He already is working on it.
Yes, I
Because you
understand,
remember, we
but
gave him parallel assignment.
we need also the formal
Another
definition of adjusted CVaR, because without the formal definition, this algorithm is not
no,
understood.
the formal definition, it is a solution of the game. It is the value of the game.
Yes, but it's not
We
fixed.
have it.
It not
Yeah.
fixed anywhere.
Yeah. No, it is my. I'm saying I'm working on it.
You need to fix it on Archive, for example, and then.
Yeah.
But this version, I suggest.
I agree with you. It's not done.
I suggest Thomas to share with us also this version. No, to make a copy and to make the same he do the week ago. To share this version, and we will sync also.
Yeah, I did share it on Google Doc.
Okay, thank you.
Okay.
Oh no, I didn't share it. I'll do it. Yeah.
Very good. Thank you very much.
Okay, then I have something to discuss with Pavlo. If you guys don't mind, we'll continue, and you may leave. Yeah.
Okay.
Bye.
Yeah, good.
But
Yeah. Oh, bye. Okay.
Bye.
Okay.
Bye, Thomas.